My name is Cameron Krogstad.
I'm Simran Agrawal.
And I'm Will Denton.
Our freshman engineering and design day project was the nuclear power probe.
Our design challenge was to design, build, and test a light sensitive monitor to measure the blue light, Cherenkov radiation, produced by NCSU Polestar nuclear reactor. This is the Polestar nuclear reactor. The science behind our project had to do with Cherenkov radiation. We had to research what it was and how we could use it to measure the light emitted by the radiation. We found Cherenkov radiation to be the light produced by charged particles when they pass through an optically transparent medium at speeds greater than the speed of light in the medium, creating a microsonic bomb that emits the blue light. Through our research, we decided that the photoresistor, which is capable of measuring the 400 nanometer blue light waves emitted by the Cherenkov radiation, for our probe. Here you can see the requirement for nuclear power probe. We were able to complete a project under the maximum budget of $40. We spent a total of $28.44 on our project. We were fortunate to have gotten a photoresistor from the resource room.
First, we had to research our topic. Cherenkov radiation is not a simple topic, and it is important for us to widen our knowledge on the subject. The research helped us understand more about our project and why we were doing it. After we finished our research, we took to brainstorming for our design. Here we have the final schematics of our probe. The main challenges we faced were waterproofing and transportation. To deal with waterproofing, we used clear PVC cement to seal the plexiglass onto the PVC so that our photoresistor could detect light. To make the transportation of the 12-foot probe easier, we put threaded connectors in the center so the probe could be unscrewed and folded in half. We also put a connector on the 2-foot end piece of our probe so that we could remove and work with the sensor head much easier. We also had to decide between using a photodiode and photoresistor. We ended up using a photoresistor. This is the probe construction. On test day, we went to the NCSU Polestar reactor and got to test our nuclear power probe in the reactor pool. Our probe was very easy to transport, which made sure our photoresistor would not move around. In the end, we got the mystery power level to be 625 kilowatts through our line of best fit from our previous test data. This was approximately a 12% error of the actual power level of 710 kilowatts.
At the freshman engineering design day, we got 7th place. Unfortunately, our sensor did not read as accurately as we'd hoped, and we got a pretty wide margin of error. If we had to remake the probe differently, we would have used Teflon tape so that the threaded connectors were completely waterproofed. We would also have soldered the wires to the battery so that it would provide a more stable and consistent connection. On testing day, we should have used alligator clips to get a more stable connection to the voltmeter. Don't hesitate to ask for help from the project guru. Start early and don't procrastinate. Be sure to test your probe prior to the test date and use more than one resistor for better and accurate results.
Overall, the freshman engineering design day was a great experience for all of us. It helped us learn new things and connect as a group. Thank you.